Hello, pre-calculus students. Welcome to the continuation of our lesson on polar and rectangular coordinates. And we have a straightforward problem here that says on radar, the location of two ships are given in polar coordinates. Ship A, 3 miles, 170 degrees. Ship B, 5 miles, 72 degrees. Find the distance between the two ships. So the first thing that we should do here is draw a picture. So we're going to draw our coordinate and ship A 3, so we go out to the right positive and rotate 170 degrees, which is about right here. Okay, so this is A, and this angle of rotation here is 170, and the length that it was rotated was 3. And we have ship B, so we're going to go out 5 and rotate 72 degrees, which is approximately here. And this is B. The length is 5 and the angle of rotation is 72 degrees. And what we want to know is what's the distance between these 2 points? What's the straight line distance between A and B? So there's 2 ways that we can do this, and I'm going to do this problem in both of those ways. And in the future, going forward, you can make up your own mind depending on what works better for you. So the first way we're going to do this is to convert to rectangular coordinates. So let's do this for A. So x is going to be 3 cosine of 170. Y is going to be 3 sine of 170. Okay. And these numbers have an actual value. I'm not going to really, not going to calculate them just yet. Just leaving it here so that you can see the math behind it. B is x is going to be, we'll call this x1 and y1. Call it x2. It's going to be the radius, which is 5 cosine of 72 degrees, and y2, 5 sine of 72 degrees. Okay. And I'm going to convert this into these coordinates so that I can just take the distance formula. So now I'll type this into a calculator. Make sure I'm in the right mode here. So we're going to go 3 cosine 170. That's going to give me approximately negative 2.9544. Same thing with sine, which gives me approximately 0.5209. 5 cosine 72. 1.5451. And 5 sine 72, which gives me 4.7553. And then I can apply the distance formula, which may have been a while for some of you, but it is d is the square root of x1 minus x2 squared plus y1 minus y2 squared. Substituting in these numbers, this is the square root of negative 2.9544, that's x1, minus x2, which is 1.5451, whole thing squared, plus y1, 0.5209, minus y2, which is 4.7553, everything squared, and that will give me a value for D. Type all this here into a calculator. Get the square root, and this is going to be kind of a nasty thing to type into a calculator. 2.9544 minus 1.5451 squared plus quantity 0.5209 minus 4.7553 quantity squared We're taking the square root of the whole thing. So it gives us approximately 6.179 miles. 6.179 miles. And that's the distance between A and B. Okay. We're going to pause it, get some new paper, and we're going to do this problem another way. So we got the exact same problem. We're going to approach this in another way, using another method that doesn't involve the distance formula. And both of these methods work just fine. And once you're done, you can decide once we're done with this example and you've mastered both ways, you can decide for yourself which works better for you. So I have ship A, which is, again, a radius of 3 and 170 degrees. Okay, so this is A. I have ship B, which is a radius of 5 and 72 degrees, so that's approximately here. So the first rotation for ship A, that's 170 degrees, and then the second rotation for ship B, or the second angle, I should say, for ship B is approximately, or is exactly given to us at 72 degrees. And so this is B, and I want to find this distance right here, the distance between A and B. So one way I've done this before is using the distance formula, but here's another way. Let me redraw this exact same triangle over here. This gives me 5, 3, and the angle in here is 170 minus 72. Gives me 98 degrees. Okay. And if you notice here, I have a triangle, and I'm going to call this A, B, and C, and we'll call this little a. This is a triangle that gives us side, angle, side. Okay, so a triangle that has side, angle, side. And if we want to solve the opposite side of that, we're going to use law of cosines. Law of cosines, okay? Which, you can look this up, but it's a squared equals b squared plus c squared minus 2bc times the cosine of angle A. And now I just substitute in the numbers. A squared is equal to b squared, whoops, I know what b is, it's 3 plus 5 squared minus 2 times 3 times 5 times the cosine of 98 degrees. Okay. Do a little bit of further simplification. This is 9 plus 25, that gives me 34, minus 2 times 3 times 5 is 30, cosine of 98. Okay. And if I want to find A, I can just take the square root of the whole thing. So this is the square root of 34 minus 30 cosine of 98 degrees. Type that into my calculator. Square root of 34 minus 30 times the cosine of 98 degrees. And you can see that gives me approximately 6.179. So A is approximately 6.179 miles, which is exactly the same as what we got before. If you look here, which is exactly the same thing as we got before using the distance formula. Now, personally, I prefer using the law of cosines because it's less rounding and it's less work. Here with the distance formula, I had to round once, 2, 3, 4 times, and then again, which in this case it didn't make a difference, but it could potentially make a difference and give you a rounding error. Here I only had to round exactly once, and that's at the very end. And sometimes I might be lucky and I might even get, a cosine of 90 or a cosine of 60 or cosine of 45, cosine of 30, and it'll allow me to give an exact answer. So both ways work. You got to be a little bit more careful if you're going to use the distance formula. The law of cosines is the preferred way that I would use.